There we go. So remember, these are cubic. So cubic. You just cross them all out. All right, so let's copy it down. F of x. Okay, so if you really want to see your A, your H, and your K, then, put the implied. The ones in the zeros are implied. Right? Okay, so what's my A value? Yes. And is that positive or negative? You already said it, but what is it? Positive or negative? Yeah. And is that, all right, concave up or down? No, we're not doing that. All right, HK, what's my H value? Okay, so what's the H? 0, very good. And what is my K? -3, perfect. So follow H, follow K. By the way, 0 is always positive. It's not a negative number, it's a positive number. So the vertex is 0, -3, which we saw when I put it in Desmos. That is that turning point, right? Of that increasing, it plateaus or kind of flattens a bit. There's a curve, and then it shoots off to infinity. Okay, so this cross. Look, it kind of has an axis of symmetry, but it's more of a rotational line of symmetry. So we'll just kind of leave it there, but you kind of, once you graph all 8 of them, then we can kind of go through and talk about domains and ranges and all that, and then end behavior. All right, on cubic function, it's always all reals. But really, we want to describe the transformation, the horizontal and the vertical shift. Remember, your H or your X axis is the horizontal shift. Your K or your Y is the vertical shift. So horizontal movement is left-right. Vertical is up-down, right? Okay, do you have a shift horizontally? No, you don't, because the H is 0. So there's none or no shift, whatever you'd like to write. What's your vertical shift? Down, right. Down 3, whoops, down 3 or down 3 units, up to you, right? Okay, so we're now going to move on to the XY table. And again, we'll talk about that rotational symmetry. Again, if you'd like to do it, you're not obligated to. All right, you can plug into a calculator. Go to the graph? Yeah? Okay. So if I kind of move this, oh yeah, I thought it was upside down for a second. XY table. Throw your vertex in the 3rd position, 0, -3. All right, do you want 2 or -2 at the top? Which one do you want? You want 2, 1, 0, -1, -2, or would you like -2, -1, 0, 1, 2? Okay, -2. Remember, it's tomato, tomato. It doesn't matter. It means the same. Okay, remember, I am going to draw lines here, but it's not like symmetry of a quadratic. Okay, so look, what you see is what you type. You have the parenthesis 1/3. Click out. Okay, instead of x, I'm going to go times -2. Close the parenthesis. I want a cube, and then -3. And that's not an x, that's multiplication. Okay, that's times. Okay. And so I get -3.3. All right, look. Here's what we're talking about. So look, from 0 to -2, this is 2 units away. Doesn't matter right or left. It's 2 units away. From -3 to -3.3, what's that difference? How much did it move? 0.3, perfect. It went 0.3 units away. So when you're talking about the positive 2, and this is right, this is in the left direction, this is in the right direction, it's also going to go 0.3 units away. That's how the rotational symmetry works for cubic functions. It's not like quadratics where they're the exact same y value. So now if here I added negative 0.3, here you're going to subtract. And so what do you get here? Well, actually here you kind of subtracted, but they were both negative, so you added. Here, though, what is that number going to be? 2.7. Negative 2.7. Yes? Remember, if you're like, nope, don't like that, that's fine. Delete it, put the positive 2. There's your negative 2.7. Oh, you can't see, sorry. Your negative 2.7. The calculator will do it for you, so don't let this part confuse you. All right, negative 1, throw that in, negative 1, and I get, okay, these are like really, oh yeah, we should have gone further, but okay, negative 3, it's pretty much the same. Yeah, we'll go like 2.9 or something like that. All right, what happens if you get something that's super, super flat like that? I would say maybe go a little farther. Go to like 6 units away. So from this to this, it's 6 units away. And you get 5. And now that's a nicer number. Okay, so if you ever get them, we're like, oh, how am I supposed to graph that? Remember, we plotted Desmos. I'll bring it back. Remember, you had that really flat landing at that vertex locator point. That's why they're all like a 1/10 away from each other, okay? All right, so let's plot it. 6, 5 is up here, so that's going to give you more of the body. Here's 0, negative 3, negative 1, 3, negative 2, whoops. 1 is negative 2.9, that's here. Huh? Yeah. Oh, yeah, sorry. Yeah, go. Negative 2 is negative 3.3. That's negative 3, negative 3.3. Negative 1 is negative 3. It's kind of the same. 1 is negative 2.9. That's up here. I went way flatty over there. Negative 2.7 is like over here. All right. So look, you went 6 units over, and you went up 5. So if you go 6 unit this way, you're going to be at that negative 5. So it looks something like this. The reason why they're so close together is because, here, let me slide Desmos over again. Oh, wait, it froze. Hold on. I don't know if I could freeze that and mess up the video. You know what? I'll show Desmos after. I don't want to mess up the video by freezing the screen. So if you want to point an exact point over here, because these are so close together, then you could pick like negative 6. Just get your calculator, substitute a negative 6. And I get negative 11. Here's negative 11, and that's about right. And you can grab more points. So if this ever occurs, if it feels like the points are so close together, it's because of that number right there. That 1/3 is between 0 and 1. So it elongates. It's that it's that horizontal that stretch that it's making it flatter and flatter. And so that's why your landing is really looking like a step. It looks pretty flat there. Yeah.
Can I see where you punched in the calculator?
Oh yeah. Bullet ring. There you go. So here, this is how, so I put parentheses, I hit the fraction, 1 down 3. but then I have to click out. Okay, I put times, like say -2, or you can put times 6, or times -3, whatever you want. You just put that number. Close the parenthesis, cube, and then the rest you know. Yeah? Okay. For those of you that now you have a calculator, parenthesis, fraction, 1/3, click out. I hit times. If you wanted to do another set of parentheses, you can. You just got to make sure you close it up. So notice my -2 still gave the same output value. If you don't want to use the x times because you think it's like the variable, then use a set of parentheses. Parentheses is multiplication. Obviously, you guys know this is multiplication. Hold on, yeah. All right, can I just stop this video? Because it's going to take a while for it to load. Okay. And then I'll help you, Isaiah.